Ever wondered how a simple ingredient like yeast can convert grapes into wine or cabbage into sauerkraut? This magical transformation is all thanks to a process known as fermentation. This age-old technique, steeped in tradition, is a crucial part of modern science and industry. It's the unsung hero behind the scenes, turning everyday ingredients into culinary masterpieces and life-saving medicines. Fermentation is a process where microorganisms, like yeast and bacteria, convert sugars and other carbohydrates into alcohol or acids. It's not just about food and drink, though. Fermentation is a cornerstone of biotechnology, playing a vital role in the production of pharmaceuticals, biofuels, and other bioproducts. From the tangy taste of yogurt to the potent capabilities of antibiotics, the power of fermentation is everywhere. It's the alchemy of biology, transforming the ordinary into the extraordinary. Now let's dive into the fascinating world of fermenters that make this transformation possible. A fermenter, often considered the heart of fermentation technology, is more than just a simple vessel. Its function extends beyond merely containing the fermenting substance. It is a meticulously designed system that facilitates the biological process of fermentation. Let's dive into the details of this biological wonder. The fermenter is composed of several key components, each serving a specific purpose. At its core, we have the vessel, which houses the microorganisms and the substrate they feed on. The vessel is typically made of stainless steel or glass, materials that can withstand the often acidic or alkaline environment within. Inside the vessel, we find the agitator system. This component ensures the even distribution of heat and nutrients throughout the vessel, preventing the formation of hot or cold spots that could inhibit fermentation. The agitator system also helps to disperse oxygen evenly, a crucial element for aerobic fermentation. Next, we have the baffle, another important player in maintaining a uniform environment. The baffle disrupts the circular flow created by the agitator, promoting better mixing and heat transfer. From there, we move on to the sparger, a device that introduces air or oxygen into the fermenter. Depending on the microorganism and the desired product, the sparger can also introduce other gases like nitrogen or carbon dioxide. Around the outside of the vessel, we find the cooling jacket. This component plays an essential role in temperature regulation. By circulating a coolant, it dissipates the heat generated during fermentation, preventing overheating that could be detrimental to the microorganisms. In essence, a fermenter is a finely tuned ecosystem, designed to create and maintain the perfect conditions for microorganisms to thrive and produce the desired end products. From the vessel that houses the process to the agitator, baffle, sparger, and cooling jacket, each component plays a crucial role in maintaining the optimal environment for fermentation to occur. Now that we know about the components, let's understand how they work together to facilitate fermentation. At the heart of the fermenter is the agitator system. Acting like an orchestra conductor, the agitator system ensures all components blend harmoniously. It mixes the contents of the fermenter to maintain uniformity. This constant churning also helps distribute heat evenly, making sure that every microorganism gets the same cozy temperature to thrive. But the agitator doesn't work alone in ensuring this perfect mix. It has a trusty sidekick, the baffle. While the agitator stirs the broth, the baffle prevents a vortex from forming. Imagine a tornado swirling inside the fermenter. That's a vortex. Not ideal for our hardworking microorganisms. The baffle, acting like the superhero it is, stops this from happening. It breaks the flow of liquid, ensuring a smooth, vortex-free environment for fermentation. Now let's not forget about the microorganism's life force, oxygen. That's where the sparger comes in. Acting like a sprinkler system, the sparger introduces air or pure oxygen into the fermenter. The bubbles rise through the liquid, creating a frothy mixture. This process maximizes the surface area of the gas in contact with the liquid, allowing our little workers to breathe and grow. But just like any living being, these microorganisms also need a comfortable environment to thrive. They can't be too hot or too cold. That's where the cooling jacket comes in. Acting like a thermostat, the cooling jacket maintains the temperature inside the fermenter. If things get too hot, it cools down the broth. If it's too cold, it warms things up. It's the Goldilocks of the fermentation process, ensuring everything is just right. So what happens after all these components have done their job? The microorganisms, now in their perfect living conditions, get to work. They consume the nutrients in the fermenter and begin to grow and multiply. As they do this, they produce the desired products, be it alcohol, insulin, or even yogurt. This is the magic of fermentation, turning simple ingredients into something extraordinary. But remember, this process doesn't happen in a blink of an eye. It takes time. The fermenter is like a mini universe where life blooms over hours, days, or even weeks, depending on the product being made. It's a delicate dance of science and nature, controlled and monitored to create the products we use every day. In conclusion, the fermenter, through its components, ensures that our microscopic workers, the microorganisms, can do their job effectively. Each part plays a crucial role in creating the perfect environment for fermentation to happen. It's a marvel of biotechnology, a testament to human ingenuity in harnessing the power of nature. So next time you enjoy a glass of beer, a slice of bread, or a spoonful of yogurt, remember the intricate ballet that took place inside the fermenter to produce them. It's not just science, it's a form of art. Stay curious, my friends, and remember, the world is full of wonders waiting to be discovered. The fermenter, through its components, ensures that our microscopic workers, the microorganisms, can do their job effectively. After fermentation, the next crucial step is downstream processing. Picture this: our microorganisms have been hard at work, fermenting away and producing our desired product. But this isn't the end of the journey. We need to isolate and purify this product from the fermentation broth, and that's where downstream processing comes into play. In its essence, downstream processing is a series of techniques designed to extract, recover, and purify the products of fermentation. It's like panning for gold, where the gold is our product and the fermentation broth is the river. But instead of a pan and a keen eye, we use a range of sophisticated methods. The process begins with the removal of insoluble products. This could be the cells themselves or any particulate matter that might be present. This is usually achieved through techniques such as centrifugation or filtration. Once we've got rid of the solids, it's time to move on to the soluble impurities. These could be proteins, sugars, or salts that we don't want in our final product. Here, we might use methods like precipitation or chromatography to separate them out, but we're not done yet. The next step is to concentrate our product. We want to get as much of it as possible, so we might use methods like evaporation or membrane separation to achieve this. Finally, we have the polishing stage. This is where we refine our product, getting it to the highest possible purity. Techniques used here could include crystallization or further rounds of chromatography. Downstream processing is a complex and critical part of fermentation technology. Without it, our desired product would remain lost in the broth, mixed up with all sorts of unwanted impurities. It's a meticulous and intricate process, but absolutely essential in ensuring that the fruits of our microorganisms' labor are ready for us to use. So we've taken a deep dive into the world of fermenters and fermentation technology. We began by understanding the integral role of fermentation technology in biotech and other industries. We explored how this ancient process of converting sugars into acids, gases, or alcohol is used today in an array of applications, from brewing beer to creating life-saving drugs. Then, we unpacked the fermenter, that critical piece of equipment in the fermentation process. We saw that it's not just a vessel for holding the fermentation medium, but a complex system with various accessory components designed to control and optimize the conditions for microbial growth. We went on to discuss the working of a fermenter, highlighting how each accessory component plays its role. The agitator, for instance, keeps the medium in motion to ensure an even distribution of nutrients and temperature. The sparger, on the other hand, introduces air or oxygen into the medium, playing a vital role in aerobic fermentation. We also touched on the importance of the fermenter's design and the materials used in its construction. Remember, stainless steel is often preferred due to its resistance to corrosion and ease of cleaning. From there, we move to downstream processing, the stage following fermentation where the desired product is separated from the fermentation broth, purified, and prepared for final use. We emphasized that while it may not sound as exciting as the fermentation itself, downstream processing is equally important, accounting for a significant portion of the total production cost. In summary, fermentation technology involves a complex interplay of microbiology, engineering, and chemistry. It's a dynamic and ever-evolving field that continues to make significant contributions to our daily lives. Subscribe for more because you won't find me later. Stay curious, keep learning, and remember, even the smallest microorganism can create a big impact.